Oh, hey. As a male poser who loves matcha, listens to Leve, Claro, Bibidoobie, I have my carabiner, I have my tote bag, got a full setup. My bad. I wanted something to show off this aesthetic even when I'm not posing. Yeah, I'm kind of tired right now. So I made this. This is the Matcha 75, based off of the same color of matcha. Ooh, this is strawberry matcha for anyone that's wondering. Like, look at that. I actually got it pretty good. So, in this video, I'm going to show you how I made this and how you can make your own. Because PCBWay sponsored this video and I've made it open source, so this full project you can make on your own. But this is technically a one-of-a-kind thing that is just for me. So I have my own build, which is pretty awesome. Let's first get a physical overview of the board, right? Up here is the Raspberry Pi Pico. And this is the brains, right? This is the smarts of everything. This is the thing that figures everything out. This does all the coding. For my PC nerds out there, this is your CPU, okay? Technically, if you delve into it, this is your CPU, this guy right here, the RP2040, but just imagine this whole thing is your CPU. For a computer, let's say that this is our computer, you need something to input into it. So that's the whole keyboard thing. The keyboard, and this is a volume knob with press input. So that is our input to control it. And then this also has an output to control the screen. This is a 128 by 32 OLED display. It's black and white, but it's cute, it's nice. And I have a little cat display running on it. So yeah. And then a whole matcha aesthetic. This is 75% keyboard. Basically, 75% means you got all the F keys, you have your arrow keys, and all that jazz. So it's a very basic layout, apart from the fact that it has these. These are 6 macro keys, and basically each one does a different thing. This is next track, pause, backtrack, heart emoji, close all windows, Marvel Rivals open, something like that. So I was able to map it to whatever I want because I'm coding this keyboard. I coded this keyboard not from scratch. I use this software called QMK, and then I put it all together into this. And I have full control over what each key does. If I wanted each key to type F, I can do that. I can map every single key to F. I have full control over what I get to do with it. That's a really neat thing with a custom board. So now that we've gone into the basics, let's delve into some, bit more nerdy things. So let's look at the actual components of the thing. So if you take off a keycap like that, you'll see these guys. These are brown switches. Brown switches are your classic, like they have a little bump and then they're a bit quieter, but they feel all right. And these are the cheapest ones I could find on the market because I kind of have a budget. So I had to go with cheap ones. These are not the highest quality and I would not recommend buying these for your main keyboard, but it's perfectly fine. I'm chill with it. Yeah, it's fine key switch. And when you open up the back, because yes, I made it open, I didn't make it like screw, because this is a bit iffy if I let it screw. Ta-da! So I'll just show you this part right now, so we can just focus on this. This right here is a key switch. So that's the thing that you saw on the other side, the one with the little brown. And the way that the switch works is kind of 2 things go together. And when they're pushed together, then they send a signal because then the electricity can go through. That's basically what's happening here. Boom. Each one has this little red thing beside it. And this is a diode. It's the 1N4148 or something like that. Nerd specs, don't worry. But yeah. So each key has its own diode, and diodes basically force energy to only go one direction. So let's say that there's a diode forcing it in this direction. I can move forward, but I cannot move backwards. Like I have to keep moving forwards. So there's a few reasons why you'd want to do that, but it allows multi-key input basically. Without that, you couldn't do multiple key input. But if you look at the traces, which I don't know if you can see very well, they're arranged in a column and row way. So there's columns and rows for each one. And this is done in a battleship style, right? You know how Battleship has, I think it's A to J, 1 to 10? And that basically lets you get 100 different points on the board. If you had just done per pin like things for Battleship, it'd require 100 pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, all the way to 100, right? But the way that they did it is 1 to 10, A to J. So that is 20 different pins that will account for 100 different things. It's a bit more work because then you have to say, oh, well, it's 1A. Oh, it's, you know, 2J. You need to figure all that stuff out. But it's really not that bad, right? And it's the same thing here, where I have these columns and rows, and even though they're not perfectly aligned, there's some curving that is done. Like these are together, and then right here you kind of have to do some weird like branching. But in general, they're pretty much all connected in a column and row fashion, using less pins and make it easier for me to actually do a build. And yes, if you want multi-key input and you have enough pins somehow for a keyboard, then you do not have to use diodes. But the CPU over here does not have enough pins. I think it has 20 pins in total, and I use all 20. So it's like, it's iffy, right? But yeah, so this is a fun board. I'll have all the files I use in the description, but I want to delve more into this board itself, and I'll talk a bit about how you can order it. So it got sent in this thing. I know it looks bad, but they had to send it in a really cheap way because DHL is on strike in Canada, and my address is on the top, so maybe don't show that one on camera. Oh God. Okay. Let's grab out PCB. So I got these PCBs in black, and black and white, in my opinion, are the two ones to go with. Green and blue look cheap because those are the classic PCB colors, but yeah. So this is a board that I can just build a whole keyboard onto, and it's decent, right? I wrote a lot of stuff, my own in-jokes. You shouldn't understand these. These are just links to different like streamers. They're my favorite people. It's called a Maya 75. That's why I named this whole board itself. But yeah, you can kind of see how all the lines are done. And I'll show it in a software afterwards to actually, you know, give you a better look at it. But that's what the whole board looks like when it's unpopulated. And it's pretty nice, right? Yeah. So we're gonna hop in some software, and I'm gonna talk to you about how you can get this board and how I made this board and how you can make your own board if you don't like my board. So we're here in Keycaps, and this is basically where I do all my PCB editing. And I'll show you my PCB. So it starts out with this little schematic, and the first thing you'll note is this. This is the Raspberry Pi Pico, which again, as I explained earlier, is basically your CPU. Just imagine it as your CPU. And there's a whole bunch of things that pop out of it. They say which row it is, which column it is, yada, 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 right? And each thing associates to something else. Let's say row 1 right here on GPIO 0 is row 1 over here, right? And GPIO 0 is general purpose input output. So basically it can take inputs or it can take outputs. And these are currently set to inputs, but you'll see over here this SDA and SCL, which is for the screen up here, is actually set to an output. So there's a lot of different choices that you have here. So just like that matrix battleship style, as I explained earlier, there's row 1, row 2, row 3, row 4, row 5, row 6, and then your columns that go all the way up to 15. You'll see that it doesn't look like there's a key right here, but that key is mapped all the way over here, which is the Rotary Encoder button, which I showed earlier. All right, so let's look at the Rotary Encoder. Rotary Encoder has 2 points, Rotary 1 and 2, and then ground. So 3 points in total for the Rotary Encoder. So Rotary Encoder 1 is right here, Rotary 2 is right here, and then ground I have mapped to 2 different planes. I have ground mapped here, and I have ground mapped here. So it's able to connect to both of them. Looking at the button side of it, right here is kind of a button aspect, where you have column 15 being in this one, and row 1 being here. And there's a diode here because it is another button, so you're just gonna have to kind of set it up as a button, right? So it follows very similar design as all the other buttons, but with this different Rotary Encoder add-on. We've got our screen. Screen uses ground VCC, which is 3V3, just 3 volts that is powered from the Pico, which is then powered from USB, and then SCL and SDA. So these 2 pins are the ones that actually send data to the screen in general, right? I added this LED here for caps lock, but I actually never used it in the final build. It is on the PCB technically, and you can see it. This is a second switch. This one is the same one as this one, and I'll show you why that is there later on. Looking down here, you have these SE switches. SE switches are kind of like the macro switches that I have set, SE1, SE2, SE3, SE4, SE5, SE6, because I didn't want to do a full nother column because I ran out of pins. If I didn't add this LED, then I wouldn't have run out of pins. But I ran out of pins, so to get the macros in, I had to do some weird stuff by putting things here. But in general, if I deleted them, it's, you know, technically not meant to be here. This is what an actual 75% keyboard will look like. If we hop over to the PCB editor, like the actual PCB itself and not just the schematic editor, you can see how everything is set. So there is a copper layer that kind of sits over everything at the moment. So it's a bit harder to see, but if I just delete that, then you can see how everything is done. And there's a lot of madness in this, but it's arranged basically how I showed you earlier. You got the Pico up here, and the Pico is the heart of everything. So all the traces, all the data lines come off of this, and red means kind of front layer, blue means back layer. It's a bit confusing on why you need that, but sometimes you need wires to cross, just like right here. So you need to switch over front and back layer so they don't intersect because they're not the same wire. Right? So it's able to go over, and if you follow one of them, you'll see that it does a lot of different stuff. So this isn't a comprehensive breakdown. There's another video by Joe Scotto that's great for that I'll link. But I'll just quickly show you all the different parts of it. So these are all the holes that everything goes into. These right here, where you'll see like a red circle, it might be blue as well at some points, is called a via. So let's say I want to go from a red line to a blue line. I have to put a via in. And they basically drill a hole and fill it up with metal or something like that. So all these just kind of go around, and you'll see how the diodes are lined up and how the diodes are actually quite nicely done, where each one, not including those ones. So each one has one side connect to the key switch closest to it, and then the other one connects the bottom of all of the diodes in its row. So that's how it's able to do the row and column thing. And then if we look over here, it has the column. It's not straight because on regular keyboards, none of it is actually straight. But you'll see that if you just follow it down, it does follow somewhat of a column style. But there is a bit of some weird stuff that has to go on to get it done, right? But overall, it's pretty nice. There's the volume knob up here, the caps lock LED over here. I didn't use caps lock LED because it's actually one built into the Pico. And it's not nice, but I didn't want to waste time to add it. There's another rotary encoder. This is the same rotary encoder, as I say right here. This is not another encoder. This is the same one, but moved. And I did this because I wanted to have more options. Maybe I wanted a rotary encoder down here. And obviously I gotta put some fun text. I put a little, I think that's a cat. It's meant to be a cat at least. All right, so I'm gonna show you my QMK stuff. So let's go through, let's first look at rules.mk. So these basically just has all the rules. It enables OLED right here, it enables link time optimization. Link time optimization either makes it faster or take less time to, or take up less space, but it takes more time to compile or something like that. But I got told to turn that on. There's this OLED driver, so basically explaining what screen it is, because SSD 1306 screens are not the only ones that are supported. And then basically the version of transport of data. So I use I2C, because the other one has some weird things where it has like 8 pins, I think total, maybe. WPM enable, yes. Basically this just enables the words per minute reader, and I can integrate it with different screen things. Enable the encoder map and enable the encoder. So going back, there's these two files here, readme and keyboard.json. Readme is pretty much empty. Keyboard.json is the one that we want to look at, which is right here. So the manufacturer is me, Oliver Higa. The board is the Maya 75. Maintainer, Oliver Higa. And then development board, the Pro Micro RP2040. So it isn't a Pro Micro RP2040. It is Raspberry Pi Pico. But I can do this because to any like computer people out there, let's say for some reason code only runs on a CPU, right? Because you're running, like you're working on a micro level, right? But it doesn't matter, right? Let's say you have your 9800 X3D, right? It doesn't matter if that thing is in an Asus motherboard or something else, right? Like, it just has to be in a motherboard to function. But what matters is the CPU. It's not about the motherboard, right? So that's kind of the idea why this works. And this is the default one, I think, that is kind of stored. So I just continue to use it. Call to row. I never changed this. I don't know what this means, but I'll leave that. Oh, I think if I turn it around where it's row to column, then it expects the diodes on the other one. So keep it like this if you're using my design. So these are just some features. Boot magic means if you hold the first key, which in this case is escape, while you plug it in, it basically puts it into boot mode, letting you flash on different software. Basically, if you write this and you compile it, then you flash on different software. But there's a boot select button on the Raspberry Pi Pico, but it's kind of just if you want to cover it up or if you don't have it. I don't know what command or console does or extra key. Mouse key just lets you input mouse key inputs, and I don't know what NK row does. I've never learned these things, but honestly, you don't have to know any of them because it all comes in this setup. Unless you want to do like mouse key input, you kind of just have to Google your niche searches, right? So over here is the matrix pins. Here are all of my columns, and here are all of my rows. You'll notice that they're not in order: 10, 11, 12, 13, 14, 15, and then like 26. Actually, I did a pretty good job. No, it is in order as best I could get it. But some of them are like off, where it's like 15, and then 16 and 17 are all the way over here. But I tried my best. This is the version 1 of the device. I didn't change it. Product ID is this, and VIN ID or vendor ID. This is all the layout. So every single key basically has to have one of these maps, and it says, hey, the first key is on 0, 0. And you might ask, oh, why does this matter? Don't you want, every single key? So going back to this, because I'm on a different computer now, you can see that there is actually nothing right here. There's nothing there, like, at all. And I don't want to have a key map to there, just in case something weird happens. So basically, I didn't map it. There's nothing there. You'll see that this one only goes to 13, but these guys all go to 14. 14, 14, 14, 14, 14. And you might wonder, oh, why is it 14 if it's 15 pins, but it starts at 0. So you see, I left out this one key here because it doesn't exist, right? So you have to think about that one. But yeah, so that's kind of a basic overview of that. Going back to our, whoa, that's a lot of stuff. Thing, let's go into key maps folder, default, and let's just go from top to bottom. Config.h, pragma, this is all stuff for the screen, and then saying where the I2C driver is. So I chose pin 6 and 7 because I had so much trouble actually implementing a screen, and I2C D1, which is the first I2C, works on 6 and 7, which is a bit weird. I've used I2C D0 before when I work on my other projects, but that uses Python and stuff. And apparently you can't access I2C D0 properly, so D1 it is, I guess. So I have SDA and SCL mapped to 6 and 7, and then I have the encoder mapped to 27 and 28. So these are all the pins that I showed earlier in the Keycap. And then this is the resolution of the encoder. So basically it's like how much it reacts, basically, if I understand that. Encoder map, key delay. I think like the key from the encoder, but the thing is I didn't map this to key from the encoder. It just shows up as something else entirely. So I'm actually not exactly sure how that one, if that one even plays into my board. And this is just a caps lock pin. For me, it's GP25 on the Raspberry Pi Pico because GP25 is the LED. Halcon F.H, this is a blank thing. Yeah, I didn't change this, you just have to put this file in. Keycap.c, this is where the real work comes in. So actually let's first look at this, mooconf.h, to show you there's really nothing here. Oh, I wonder if I set this to true, then I could use I2C 0, but whatever. I'm curious, but it's fine. All right, so this is the full setup here. This is where the bulk of the work gets done. So we got QMK keyboard. You basically have this thing where it randomly generates a number in a safe range, and then it sets it to it. and it's kind of weird. It's kind of numbers that won't intercept with other things. These are just basically macros. So for example, my Marvel Rivals macro set to this, where it presses left GUI, then types in Marvel Rivals, and it waits like certain amounts of time. Press enter, and then types left and then enter. Here, I'll press it right now so I can show you. The left and enter part rarely works, but it's meant to do this. And now it'll open. Yeah. So then this is the key map. Basically, I just mapped everything. You have to remember that I had those weird macro keys mapped in annoying places. Right, so I had to figure out where to put those. But in general, they'll sit like this. This is the stuff for the encoder. Code for encoder, just simply volume up, volume down. If your encoder's backwards, just change which one's volume up and which one's volume down. That's easy. This OLED stuff, I'm not going to talk about this like I know it. Code will be linked in the description for this specifically. Right, so if you want to do this, because I took someone else's code for this. But yeah, that's basically all the code for my keyword. PCBWay offers many services in general, offering just the regular PCBs like you can see in this video, flex PCBs, PCB assembly, also known as PCBA, meaning that they install smaller parts for you. So example, for a keyboard, they can install smaller diodes, and it just really makes your job way easier to do, right? They also have the 3D making services, seen in 3D printing, resin, and CNC. I actually love the stuff they've made, and it is quite a bit pricier than other options, but it is really, really nice, and they have loads of options that no other company can really offer. All right, let's talk about how you get each of these parts. So I'll have in the description this Raspberry Pi Pico, this rotary encoder, the keycaps, the key switches, the diode, this screen, and yeah. Oh, also the stabilizers. So that's all the parts that you buy from AliExpress, because those are all AliExpress links. And then the case itself is 3D printed. That one's uploaded to Maker World, which is the Bamboo Labs one. So you can print it from there. And then the PCB itself is uploaded to PCBWay. And you can basically just buy it directly from them. And apparently I get a kickback. I don't know if I do, but please buy it from there. And please buy it. I'm looking for more free stuff. But yeah, so that's how you get all the different parts. And I'm not going to give you a tutorial on how to put it together. You need to figure that out yourself. It's very, very simple. Again, there's holes for keycaps, holes for switches. Most things only go in one direction. Like the keycaps can only go in one direction. The key switches can only go in one direction. The diodes can only go in one direction. The rotary encoder can only go in one direction. Like, you really aren't messing this up. The diodes are the main thing where you have to like figure out the way that they're meant to go. I'll show you. So there are these red crystals. There's a black line down here at the bottom, and you want the black line to be the furthest down thing. That's it. That's all you need. Put it all together. Slidey case, just boop. And yeah, you got a really cheap keyboard. To be honest, this is actually not that cheap. This is what, like $60 maybe? $50? I don't know USD. It's like 90 Canadian or something. 60 bucks. Not bad, but not the best, you know? All right, so let's have a look at how you would order the thing from these different companies. So this is not the PCB, okay, because I'm using a different computer, as you can see right now. So I don't really have access to the other one at the moment, but we load it up, we have a thing here, and we can just press this, our PCBWay plugin for KiCad. So I got this, just hopping back over to Chrome, boom, right here. This can be linked in the description, it might be, and boom, so you just import the zip into the library, and now you have this PCBWay button. So this one is a much bigger file than mine, and it'll take a lot more time to load in. Oh, that's pretty fast actually. So this is an unpopulated board, for example. Not sure if it's able to figure it out, but as you can see, it's just that simple. I say where I am. I'm not in America, but sure. Save to cart. Oh, quantity. I want 5. Yeah, you just have to make a few choices here. Save to cart, and I don't think it breaks any of those. And I sign in, whatnot, and boom, it's in my cart. And I can basically just wait for my rep to check it, and then I check out. So if you want to look at my PCB, for example, I've uploaded it and you can just add it to cart, and you can change the little things. Like I like hassle lead free because I don't like to bring lead in my house, and it's just 80 bucks right there for 4 of them. That's like $20 shipping or something. But yeah, so you can just buy it from right here, and you can buy some PCBs. So it's simple work. If you want the case that is on it, you can also take the 3D models and import it into the PCBWay software, and you'll be able to also 3D print some stuff. So I've actually been using this keyboard. Like, this is genuinely the keyboard I've been using for the past while, and I play games with it. It has 1,000 hertz polling, because that's what the Raspberry Pi Pico has, and I have a microphone next to the keyboard so you can hear it, but it works very well, and like there's no weird like reaction. There's nothing that really goes wrong with the keyboard. It is just a perfectly good keyboard. Right? Yeah. So let's quickly recap on this cool keyboard that I built. 75%, it has the 6 macro keys, it has a matcha style, it has its own Raspberry Pi Pico that I'm able to code myself, it has the screen down here, it has a rotary encoder that you can push in, and I've coded it to basically do what I want. I created my own PCB to hold everything together, I created a case that can slot onto everything, and overall it's been a really fun build.